Chapter 5 test that we had just recently. So it says the derivative of distance is velocity, and derivative of velocity is acceleration. D is the distance, velocity is B is velocity, and the time. The object accelerates, that means the velocity is increasing. The velocities are in meters per second, and T is in seconds. And determine left 6. So you have to split it into 6 intervals. 1, 2, 3, 4, 5, 6. And we want to use the left side, which is this side of this interval. And each interval is 3, so I got 3 times, and the left side of the first one is 2 high. The left side of this one is 5 high. Left side of this one is 7 high. Left side of this one is 8. Left side of this one is 10. And the left side of this one is 15. So, 25 and 15 is 45, 47 times 3. Did I do that right? 25, 33, 45, 47 times 3. 3 times 7 is 21. 3 times 4 is 12, 13, 14. And this would be the area, and I'm taking seconds times meters divided by seconds, which is meters. The mid 3, so I got to split this into 3 intervals. 1. From here to there is 1. From there to there is 2. From there to there is 3. And I'm supposed to do the midpoint. The interval is 6 wide. The midpoint of this one is 5 high. The midpoint of this one is 8 high. The midpoint of this one is 15 high. So 28 times 6. 8 times 6 is 48. 6 times 2 is 12. 168 meters. What do these values represent? The area under velocity curve tells you the change in distance or displacement. Distance if it's absolute value, but these are all positive changes, so we don't have to worry about that, but displacement is probably the better answer. Over the time 0 to 18 seconds. That's 1. 2. Determine the lower estimating value. So we could do R3, which means we'd go to the right of 3 intervals. To right of 3 would be, there's 1 interval, and using the right side on the curve. And the second one would be here, and the third one would be here. Now if I did left 6, the left side would be on the curve, so the first one, and I'd do it 6, and there's 6 columns here, so I'd be doing this one. Then for this one, I'd be doing there. Then I'd be doing there. Then on the left side of this one, I'm on the curve right there. On the curve right there. On the curve right there. The left always generates extra. Area on a decreasing graph. So R3 would be smaller, and so then it says determine it. So R3 would be, if I got to divide it into 3 intervals, 1 would be here, 2, and then 3. And I want the right side on, so the right side here is 5.5 plus the right side of the next one is on the curve, and that's about 2.4, 2.3, and then the right side on this one is on it at about 1.8. And we got to take it times the width of this, and that's from 0 to 1, which is 1. So this would be 7.9, 8.7, 9.7. And we don't know what this is a graph of, so we can't put on units on this, but the area is 9.7. Number 3. This is the depth of the snow in inches on a patio after 8. So after 8, so 1 would be 9 p.m., 2 would be 10, 3 would be 11, 4 would be 12, 5 would be 1 a.m., 6 would be 2, 7 would be 3, etc. So this says at 5 there's 6 inches, because F is the amount of inches. At F of 5, which is 1 a.m., 1 a.m., 6 inches. At 11 p.m., there is 4 inches. At 9 after with 3, 4, 5. At 5 a.m., there's 18 inches. From 7:03 to 5 a.m., it accumulated plus 2 inches. Okay? And from 1:30, which would be 9:30 p.m. to 1 a.m., to 1 a.m., it increased by plus 5.5 inches. So what was it at 7 hours after, at 3 a.m.? Okay. So to get that, F of 7, let's see, there's 7 here, and 7 to 9, it went up by 2 inches, and 9 it's at 18. So 18, taking off the 2 inches that accumulated, it's 16 inches of snow at 3 a.m. B, how much did it go up between 11, 3 is 11 p.m., and 7 is 3 a.m. 11 p.m. to 3 a.m. Well, at 11 p.m. there was 4 inches, and at 7 not 7, but f of 7 was 16. So f of 7 is 16, and 3 was 4. So between 3 hours and 7 hours, it went up 12 inches. So it went up 12 inches increase. And now we got to get the times right between 3, which is 11 p.m. 11 p.m. and 7 past is 3 a.m. That came from 16, no, 16 minus 4. C, how deep was it at 9:30? Well, from 9:30 to 5, it went up 5.5 inches, and it's 6 there, so it'd have to be 6 minus the 5.5 it went up to go backwards, and it comes out to be 0.5 inches at 1.5 hours after 8, which is 9:30 p.m. And finally, 7 to 9, that's 2 hours. And from 5 to 7, 5 was 6. At 7, it was 16, so that's 10 inches increase. So 10 inches in 2 hours, which is 5 inches per hour, is the rate of increase between 5, which is 1 a.m., and 7, which is 3 a.m. Okay, 4, we have an even function, which means it's symmetric with the y-axis. What it does on here, it does on this side. And it says from 0 to 2, it's 3. Area is 3 from 0 to 2. So I'll make some kind of curve here and say that that's plus 3 by 2. Here's 0. And from negative 2, which since it's symmetric with the y-axis, this has to be plus 3 from negative 2 to 0. But from negative 2 to 5, there's a total of 8. So this is pretty small out here. Another plus 2, making a total of 8. So how much is there from 0 to 5? 0 to 5, there's 3 plus 2, which is 5. How much is there from 2 to minus 5? Well, there'd be 2 out here, but we're going from 2 to minus 5, so that would be 6, 7, 8, but we're going backwards, so it's minus 8. And how much is it from minus 5 to 5? Well, since these are positive 5, and this is another positive 5, that's a total of 10. And here's something that shows the work. So I went through this in class, but I'll do it the long way and then I'll do it the short way. So if we had to integrate this, and cosine of 2t we can integrate. If we let u equals 2t, then du would equal 2 dt, and du divided by 2 is dt. Then the integral from This will change now from new units to new units of cosine of u, and dt, because u is 2t's, that's there, dt becomes du over 2, and we still have to differentiate that with respect to x. So the half comes out, and the integral of cosine of u is sine u. Derivative of sine is cosine, so the integral of cosine is sine. And we got the half. And that would be evaluated from something to something. I didn't change the units. But then we'd have to take the derivative of that with respect to x. So if I change this u back to t, then we can put the limits in here, and this would go to, still have to take the derivative with respect to x, 1/2 sine of 2t evaluated from -2 to 5x, which would be, we still have to take the derivative with respect to x, put 5x in here, and we get 1/2 sine 2 times 5x is 10x, minus, put -2 in there, we get 1/2 sine of -4. So now if I take the derivative of this would be, derivative of sine is, I'd have the half, derivative of sine is cosine of the angle, times the derivative of the inside, which would be times 10, minus, and the derivative of a constant is 0. So this becomes 10 times a half, 5 cosine 10x. Now let's do it the easy way. If we put the derivative and the integral are going to try to cancel each other. And you notice that when we put the -2 in, it became a constant that we lost because we're taking the derivative of it. So we can just put the 5x in for the t, and we get cosine of 2 times 5x, which is 10x. But we're putting 5x in, and we had to take the derivative of that 5x, which came out and canceled with a half and made just a 5. Just take the derivative of this times cosine of 2 with the t replaced with the 5x. That's it. So this could have been done in one easy step or all of this. Determine the indefinite integrals. So to integrate x to the -1/2, you add 1, which would be 1/2, and then you divide by 1/2, plus, if you integrate 5, the derivative of what is 5, and that'd be 5x. And if you take the integral of cosine, that's negative sine, and there's a negative already, so that'd be plus 2 sine of x plus c. And this is the same as 2 square root of x if you want, plus 5x plus 2 sine x plus c. This one, you might want to try u, but I think it's a lot easier. Just put the x squared under each of these. When the addition or subtraction is the numerator, we could split it up. This would be the integral of 5x over x squared minus the integral of x to the negative 1/3 over x squared dx. So one of the x's cancel, and we just have the integral with a 5 on the outside of 1 over x dx minus, and taking 2 from a minus 1/3 is x to the minus 7/3 dx. And integrating 1 over x, that's ln of x, absolute value of x, minus, and integrating this, so one more, negative 7/3 plus 1 would be negative 7/3 plus 3/3, which is negative 4/3. So the power is going to go to negative 4/3. And we have to divide by negative 4/3, which means multiply by negative 3/4. These cancel, plus c. This one, do not make it hard. There's a 3 in both of these, so it would factor out. And x squared minus 1, now if it was x squared plus 1, we might be trying to do tangent, inverse tangent or something like that. If it was 1 minus x squared with a square root, we might be trying to do the inverse sign. But x squared minus 1 factors. And then these would cancel, and so this is simply 3 times the integral of 1 over x minus 1 dx. If you're not sure how to integrate that, you can let u equal the x minus 1. du would be dx. So this becomes 3 integral of 1 over u, and dx can be replaced with du. So that becomes, that's u to the minus 1. We can't use the power rule, but 1 over u becomes ln. So this is 3 ln absolute value of u plus c. And now going back to x's, we get 3 ln absolute value of x minus 1 plus c. This one looks like x squared plus 1 plus 4, but that's what the tangent one looks like if you factor a 4 out. So if we do that, we get the 4 is coming out of the denominator, so it becomes 1/4, 4 in the denominator, integral dx over, so 4 times what makes x squared? 4 times 1/4 x squared makes x squared, and 4 times 1 makes 4. So now we have the 1 that we need. Now we got to have something squared here, so we're going to write this as 1/4 the integral of c. 1/4 is 1/2 times 1/2, so I can put the half inside, so I can call this 1/2, or x over 2 squared. That would be x squared over 4, which is 1/4 x squared, plus 1 dx. And if I let u equal the x over 2, du would equal, that's like a half x, so that's just 1/2 when I take the derivative, dx, multiply by the 2, and I get 2 du equals dx. So I'm going to replace dx with 2 du. So I'm going to have the 1/4 integral of 1 over u squared plus 1 times 2 du. This 2 can come out and make 2/4, or 1/2, the integral of 1 over something squared plus 1 is tangent inverse of u plus c. And then we'll put u back in, which was x over 2. So we get 1/2 tangent inverse of x over 2 plus c. Final page. So, absolute value, x squared minus 2x is a right side up parabola. And by factoring out an x, we can see this is x times x minus 2. So it crosses at 0 and plus 2. So we have a parabola that goes through 0 and 2. But it says absolute value, so this wouldn't be negative down here. It would turn over like this. And we're supposed to find the area between there and then up through 5. So there'd be some big positive area there. This area would have been negative if it's just the parabola, but it's positive because its absolute value flips that over. So we need to split this into two integrals. The integral from 0 to 2 of x squared minus 2x dx. And that would give us this area. But we want to make it positive because we want this area. So we'd have to put a minus on that. Then add to it from 2 to 5, this area under the parabola would be positive, so we're just going to do from of x squared minus 2x dx from 2 to 5. So we have minus, parenthesis, integral of x squared is 1/3 x cubed. The integral of minus 2x is minus x squared, evaluated from 0 to 2, plus the integral of that is the same thing again, 1/3 x cubed minus x squared, evaluated from 2 to 5. Now we put the 2 in, we get 8/3. And we put 2 in there, we get minus 4. That's the 2 in here. Minus putting 0 in there. And we got to take the negative of all that. Plus, now we got to put 5 in here, so we get 125 over 3 minus 5 in there is 25. Minus, put 2 in there, and we get the 8/3 minus 4 again. And so now we got to figure this out. So 8/3 is 2 and 2/3 minus 4 is minus 4/3, and the minus of that is plus 4/3. 3 in there is 4, and 3 into 5 goes once, and 2/3. So we got 41 and 2/3 minus 25, which would be 16 and 2/3. And this is 4/3. And we got to subtract that. So 16 and 2/3 minus 4/3 is 15 and 1/3. So we got 4/3 plus 15, and we have plus 4/3 and minus 4/3. So wait a minute, I messed up a sign here, I think. This would be minus 4/3, and so minus and minus is plus. So we got 4/3 plus 4/3, 8/3. 8/3 is 2 1/3. And so I've got 17, 18. That's minus 2 2/3. Oh, this is minus 2 2/3. So this will be plus 2 2/3. Excuse me. That's what this is. And we got to subtract that. It's minus, and so it becomes plus. So we got 2 2/3 plus 1 1/3, which is 4 3. 4. 4 plus 16, that's 20 2/3. Still not coming up right. 6. Getting messed up here with the fractions. 8 2 1/3 minus 4 is minus 4/3, and minus of that is plus 4/3. Minus 0, or plus 0. 125, let's just do all thirds. So this is 12/3. 8/3 minus 12 is minus 4/3, and minus and minus is plus 4/3. 25 is 75/3. So 125 minus 75 is 50/3. And then 8/3 minus 12/3 is minus 4/3. Minus minus is plus 4/3. So this is 58/3. That's the correct answer. I had some trouble there with the fraction, sorry. Okay. B. Well, this looks messy, so maybe that's what U's got to be. That's about your best guess on this, so that's what I'm going to guess. U equals 1 minus ln 2x. Then du would equal, derivative of 1 is nothing. Then we'd have a minus, and the derivative ln of something is 1 over the something times the derivative of the inside, which is 2 dx. These 2's cancel, and multiply both sides by a negative x, and I get minus x du equals dx. So this becomes the integral, and if I put in 1/2 in here, ln of 2 times 1/2 is 1, ln of 1 is 0, 1 minus 0 is 1. If I put 2 in here, I got ln 4, so I got 1 minus ln 4. That's my new limits with u. Then I'd have e to the u over 3x times minus x du to replace the dx. So the x's cancel, and a minus 1/3 comes out. Integral from 1 to 1 minus ln 4 of e to the u du, and the integral of e to the u is just e to the u, so we get minus 1/3 e to the u evaluated from 1 to 1 minus ln 4, which is minus 1/3 e to the 1 minus ln 4 minus 1 in here, e to the 1 is e. And that's that. C. Well, the derivative of secant squared could be messy. The derivative of secant is secant tangent. It's going to be messy. The derivative tangent is secant squared. That might cancel that. Derivative of secant tangent theta plus 1 would be secant squared also. So I think I'm going to let u be tangent theta plus 1. Notice I went through and just thought about the different things and what they would produce. This one will produce du equal to secant squared theta d theta divided by the secant squared. I get du over, that's what d theta will be equal to. So you have to know your derivatives to be able to do some of these. Now, if I change the limits, if I put 0 in there, tangent of 0 is 0 plus 1 is 1. Tangent of pi over 4, you need to know unit circle. Tangent of pi over 4 is 1 plus 1 is 2. Integral of secant squared theta over 2 square root of u, and d theta becomes du over secant squared theta. So I have the integral from 1 to 2. The 2 there would come out as a half. The square root of u in the denominator is u to the negative 1/2 du. It wouldn't be any ln because it's not just a plain u. It's in under a square root. It's not. If it was u squared, it still wouldn't be. Okay. So now, the power rule says add 1 to negative 1/2 would make it plus 1/2, and then divide by the half. So I get 1/2 divided by 1/2 u to the plus 1/2, evaluated from 1 to 2. Well, this is gone, and I put 2 in there, and I get the square root of 2. And if I put a 1 in there, the square root of 1 is 1 minus 1. All right. If I put the dt over on this side, and then integrate, the integral of 1 is just the variable y equals the integral of this. If I can let u equal 2t, but you should be able to see that this is going to be 4. Integral of cosine is sine 2t. What we'd have to divide by 2. Think of it this way: if I took the derivative of sine of 2t, it'd be cosine of 2t times the 2, which would cancel the 2, and leave me 4 cosine 2t. Similar idea for integrating e to the 2x. It's going to be negative, and it's going to create a 2 in the denominator, e to the 2t. And if you think about this, derivative of e to the 2t is e to the 2t times 2, which would cancel the half and be e to the 2t, plus a constant. And it says when t is 0, y is supposed to be negative 3. Negative 3 is supposed to happen when t is 0. Sine of 2 times 0 is 0. Sine of 0 is 0 times 2 is 0 minus 2 times 0 is 0. E to the 0 is 1 times the negative half is negative 1/2 plus c. So if I add a half, I get negative 2.5 for c. So y equals 2 sine 2t minus 1/2 e to the 2t minus 2 1/2. the only function that you can take the derivative of and get the original function back times a constant is a function that has a constant e to some constant times the exponent, e to the constant times exponent. The derivative of this would look the same except for the derivative chain rule says times k. K times it. So k has to be negative 0.2. So we know that's what goes here. And when t is 0, 0 times anything is 0. E to the 0 is 1 times c has to be 5, and so c has to be 5. And so our equation is y equals 5e to the minus 0.2t. If you take the derivative of both sides, you get y prime, and you'll get this to be minus 0.2 times the original y, times that. So there's the answer to B, and for C, we're supposed to put 10 in there, and we get y of 10 is 5e to the negative 2, which is 5 over e squared, and we could type that into a calculator. Comes out to be 5 divided by e squared is 0.67667-ish. And